Welcome to this Kool Kat Science video. In this video, we will learn a technique that engineers use when choosing materials for a project. Our STEM team is working on a challenge today. We're building a kite for a kite competition and we need to select the best spars for the kite. The spars are often referred to as the bones of the kite. They are long, thin sticks made of wood, plastic, carbon fiber, or a similar material. Our team has decided that the ideal spar is lightweight, strong, and flexible. In our test today, we will measure these properties. To find material strength, we will measure the amount of force needed to bend a spar a short distance. The more force needed to bend the spar, the stronger the spar material. Flexibility means that the sticks can bend without breaking. Our team decided the best test of flexibility was to measure how far a spar can bend before it breaks. To compare our different spar materials for flexibility, we will be doing destructive testing. That means we will apply stress a little at a time to samples of each material. By destroying our samples in a controlled way, we can learn how much stress each material can handle. The first step is to prepare samples of each material. Each sample should be the same length. To test for strength, we will brace a spar at the ends and apply force in the center. Our test will be to find the amount of force needed to bend the spar 1/2 inch. To test for flexibility, we will brace a spar in the middle and apply force at the two ends. Our test will be to find out how far a spar can bend before it breaks. For our test, we are using a modified version of the Kool Kat Science Gizmo rig. The Gizmo rig is an inexpensive test stand that can be configured for all kinds of STEM projects. I'll put a link to the plans in the comments below. Both tests measure the distance that the spar bends. To make a scale for measurement, we use a strip of 1/4 inch graph paper and number the lines from 0 to 20. Use masking tape to position the scale for each test so the 0 is under the spar in resting position. Let's set up for the strength test. First, center the spar behind the ruler post so that at least 1 centimeter of spar extends past the post on each side. Pass the spar through a paper clip. We used an ideal style paper clip with the loops bent so they overlap. Hook a spring scale on the loops of the paper clip. If needed, reposition the paper scale so that the 0 line is under the spar when it is snug against the posts. Pull gently on the spring scale until the middle of the spar bends out to the number 2 line. That's 1/2 inch. Use a spring scale which gives a good reading. If the spring scale goes to the maximum value without bending the spar to line 2, then switch to a higher rated spring scale. Record the newtons measurement of the force needed to bend the spar 1/2 inch. Let's set up for the flexibility test. First, move the metal top bar down to the deck and fasten it to the mounting bolts using an angle iron on each side. Attach a large fender washer to a heavy string and tie it to the metal bar. Pass the spar through the fender washer. That will be the brace. Cut a piece of heavy string 2 times longer than the spar and tie the ends to opposite ends of the spar sample. Use a slip knot so that the string grips the spar firmly. Position the spar so the fender washer is in the center of the sample. If needed, reposition the scale so the 0 line is under the spar when the pull string is pulled taut. Put a reading ruler on the scale with the back edge on the number 3 line. This ruler is used by the observer to direct the tester. The tester pulls the string to bend the spar until the ends are above the back of the reading ruler. The observer moves the ruler to the next line, and the tester pulls the string till the spar ends line up again. Keep repeating this process, stopping at each line. When the spar breaks, the flexibility reading is the previous line. After testing, gather your data. Use the challenge cards to rank the samples according to their test performance. You may have noticed that the strongest material doesn't do too well in the flexibility department. By ranking our samples, we can find the material that best serves all of our criteria. After testing all our samples, the team knows much more about the best material for our kite spars. By doing destructive testing, we identified the materials most likely to survive flying high in the sky for the kite competition. Our Kool Kat team hopes you enjoyed this demonstration of destructive testing. This is a very common technique used in engineering. For more tips, tricks, and STEM techniques, follow our channel, Kool Kat Science. Until next time, stay curious, and whatever you're working on, don't give up.